All right, great to see you. I'm going to talk about Filecoin regions and how we're going to use IPC to scale Filecoin. And most of this talk I gave at the PhilDev Summit in Iceland in September. So you can watch, there's another talk about this that goes into more depth. And there's a really good discussion with a lot of the PhilDev Filecoin developers talking about how various things would work. So if you're interested in this kind of thing, check out that talk. And there's, of course, a ton of questions to figure out of how we're going to do this. But this is a way of getting you thinking about how to restructure a protocol as large as something like Filecoin with IPC. And remember that we have been designing and building IPC with networks like Filecoin in mind at the center. So we've seen a lot about the IPC model of the world, but just for completeness, especially if somebody's watching this talk that wasn't part of this conference, I'll just repeat a bit of the high level. There's a very large-scale consensus bottleneck when it comes to blockchains today. When you think about the large-scale data use in most of the mainstream applications in the internet, they use an enormous amount of transactions. We're talking about millions to billions of transactions per minute, or per second as well. And we need to get blockchains to scale to that level in order to be able to onboard consumer-oriented applications. To really reach web scale and to build planetary scale applications, we need to be able to deal with billions or trillions of transactions per second. And that's something that the industry is not yet going towards. It would also be really useful to have partition tolerance and to have block times that are extremely fast. So think of sub-second block times. So what we're shooting for is something like this, where we want to orient towards getting the level of scalability that the modern cloud has and the level of ease of developer experience while preserving the very high security, verifiability, and so on that blockchains give us. So there's a broader kind of landscape around how IPC thinks about computation and takes a lot of inspirations from cloud models and compute scheduling systems. And IPC also gives us the ability to evolve the individual consensus protocols in a per subnet basis to be able to explore many different kinds of protocols and evolve the Filecoin network through that exploration. I'll explain the overall model of IPC here with this tree on the right. I think everybody here has probably heard it by the fifth time already, but somebody watching just this video probably hasn't. There's a tree structure. Each node in this tree is a full consensus, a full blockchain. Now that blockchain in the leaves of the tree could be as small as a sequencer in a rollup type setting where there's a single node. Now, of course, in the middle layers, you would want many more nodes and so on. Or if you're doing zero knowledge validation or verification, then you may not need that. And so think of really orienting the scalability of that chain towards splitting up the state into these different regions, and then thinking of the entire state of a particular blockchain as the union of all the state here. So don't think of the state of a blockchain as just a single state root and the state tree of that single chain. Think of the whole state as a whole set of trees that are eventually consistent. So this is where kind of the traditional cloud environment starts moving back in, which is when you're computing on one of these subnets, you have eventually consistent read state. You might be reading an outdated copy that it might be a little bit outdated. And of course, when you want to do any write, especially if there's something sensitive, then you have to pay the extra cost of synchronizing with that other subnet, and that might be a longer execution. RPC takes a lot of inspiration from virtual machines, containers, operating systems, and kind of the E-writes agoric model of the world in terms of message passing and so on. Also, a lot of inspiration from Erlang. And so we've built the IPC technology out of the tech of FVM, which came out of the Filecoin community and the Filecoin project, and we've married it to this very strong distributed runtime to enable us to scale blockchains with this tree structure. So great. So that's the IPC model of the world. Now let's talk about Filecoin and what we need. So in the Field Dev Summit recently, we had a whole bunch of discussions about what is the scale that Filecoin needs to reach in the long term. We're already at exabytes of storage, which is amazing, but we really need to hit a massive scale, much larger than that. We walked through. There's a talk where we went through establishing kind of market level targets, then deriving from that a set of target characteristics that we want to hit, then figuring out a set of system constraints in order to hit those targets, and then that gives us a set of improvements that we might need to bring to the network, and that gives us an improvement trajectory through a set of improvements that we might bring in earlier, before others, and so on, to navigate the network towards that. Worth highlighting here that the scale that we're talking about for long-term Filecoin success is enormous. We're talking about zettabytes of data. That's 1,000 times bigger than where we are now. A zettabyte is a truly gargantuan amount of storage. And when you think about the number of operations in the internet, from the number of requests through HTTP, or the number of writes or regional writes to databases, or the amount of data objects that are stored and tracked and permissioned and so on, we reach a truly massive scale. So when you think of any of these numbers, for the broad success of something like the Filecoin network to reach success at a global scale, to get to something like 10% of the market there, which is certainly the ambition of the whole community, and beyond that, to get to that scale, we need to be hitting this kind of scale. It's enormous. And so in order to be able to do that many operations, to be able to track that many objects, to be able to track that many updates over time, especially once they become read-writable, we need a scalability structure for the whole network that can yield something like that, which is why we've been working on things like IPC for this whole time, to be able to have the scalability primitives to be able to deliver on something like this in the long term. Now, separate from being able to just hit those raw targets, there's a whole set of things that we want to do along the way in the Filecoin network, like bring writes of various different sizes, from small kilobyte writes, kilobytes and megabytes, all the way to on-ramps that can store petabytes or exabytes or things like that. We want to be able to do things like write aggregation into buckets and have on-chain collections. We want to be able to have all of these things be mutable writes, so you can kind of update those collections over time. We want to be able to have very low latencies in reads. We want to be able to use various different storage media types, and so on. All of these things, in addition to these things, we have a whole set of system components that we may want to have, things like deals for very small amounts of data, aggregate deals that represent whole collections of deals, mutability or composable deals, and then we'll need indexing over all of this data. So all of these systems that we have to build, that's where IPC comes in. IPC can give you not just the region structure to scale Filecoin, but it can also give you special purpose networks that can support the entire Filecoin network. So you can think of running a small subnet in the Filecoin network, providing some concrete service, running a set of programs to help upkeep the network. So whether that's upkeeping a set of data collections, upkeeping a set of buckets, updating reads or writes, and so on. Think of the way to have on-ramps into the network as potentially being these subnets hanging from the mainnet. So when I think of something like Web3.storage, being able to decentralize Web3 storage comes through, IPC gives us a very straightforward way to do it, which is you create a subnet that represents Web3.storage, and you do all of the writes through that subnet. And then when and you treat the state tree as a cache, and as you have an option, you either page things out into SPs, and then you fault to SPs and bring it back, or you just fan out and scale Web3 storage using the IPC fan out vertical scaling component to be able to grow what that application is and have it continue. So think of being able to solve all of the tons of different problems that the Filecoin community has by building special purpose networks using IPC, like special purpose subnets to solve those problems. Cool. So I've mentioned this kind of regions thing. So what's that? Let's dive into that. And this is something that I've been working towards for a very long time. So from the very beginning, when I started thinking very deeply about blockchains, it always really bothered me that these networks are not partition tolerant, and that they force speed of light around the entire world on everybody. We really need to get to a much faster and much more resilient structure. And IPC gives us this, right? So IPC lets us have chains where any chain can have child subnets. It's fully recursive. You have availability through partitions because the subnets can continue operating. You can add more subnets to give you the horizontal scaling. You can fan out deeper to represent that subtree to the rest of the world as a larger and larger machine. You can think of very fast block times in some of these subnets and so on. So we can use this tree structure to bring the concept of regions, which is very common in the centralized cloud, into Filecoin. So think of dividing up the world into a set of regions, and you create subnets for those regions, and you can have storage and retrieval and so on in that space, and align all of the clients with the storage providers and retrieval providers and so on that want to provide the service right there. That would speed up the operations for all the users. It would significantly drop the costs for SPs in terms of the gas costs on the main chain. It would make the chain faster because it doesn't have to go all the way around the earth anymore. You can have a much faster block time. You could and then you can sort of keep fanning down, right? So what would that look like? I want to work through an example with folks. So imagine that you have the L1 here is the Earth Filecoin mainnet, and then we start by just adding two subnets. We can have like the Asia subnet and the North America subnet, and picking those two because they have like some of the largest amounts of capacity. Then maybe we underneath that add specific regions. Here the concept of a region maps to the region concept in the cloud, where it's a specific data center. So here when we say maybe Hong Kong or Shanghai, we might actually want to pick a specific data center, because you could have multiple data centers in that region. Usually you don't see that in the cloud, because the cloud is usually only has one data center in that particular region. Sometimes they have like A or B now, but so we should have some nomenclature here where we can specify the data center. And of course, you can keep adding all the continents. And you can even introduce the concept of an availability zone, which is also a cloud concept that gives you some isolation and redundancy within the same data center by using IPC. You can just treat that as a separate subnet, and you have the full one-to-one mapping of the traditional cloud scaling concepts straight into Filecoin. So this gives us the ability to properly scale the entire Filecoin network to something that is competitive with the centralized cloud environment. Now, a whole bunch of the hard questions are like, great, so what does this mean for all of the different contracts that are today on the Filecoin L1? How do those things move down? Like, should storage providers add storage in the L1, or should they add storage in the, that's, again, very expensive. We want to be able to leverage the increase in throughput here, so storage providers should be able to add storage in the subnets. How do we know that's safe? How do we know that's secure? Does that grant you storage power in the mainnet? There's a whole bunch of interesting hard questions to solve and work through there, but that's the work that we'll have ahead in order to be able to actually do this. But we don't have to start with something that hard. We don't have to, we can keep working on that along the way. We can do some easier things like put some of the storage on-ramps here, put the retrieval providers that need to provide very low latencies in these environments, put some of the applications, the games or the computer for data stuff through this. We can create this region structure and deploy it into the network way ahead of having to figure out like all of the storage power questions, and then over time go resolve those questions and then start migrating the storage there. One other really cool thing that might drop out of this is that we have very high certainty on the location here. So here in the regions, I haven't yet talked about verifiability. How do you verify that somebody is actually where they say they are? The Filecoin network now needs a proof of location network to really certify that a particular SP is precisely where they are saying they are. We need that for a lot of reasons, because clients want to guarantee that the data that they're asking to store is actually stored in the correct location. We also need that because we want to be able to increase the block time here and have it go much faster. And so once we have a proof of location, we can also use that to improve the proofs of replication. So we might even be able to construct, once we have a secure proof of location, you can then use much faster proofs of replication. There's good proposals for proofs of replication around this, where you can show and demonstrate that you have multiple copies if you can run an easy proof of storage faster than the speed of light going to some other location, right? So you basically run several proofs of storage in different locations in the world simultaneously, and you have a verifiable way to check that there are multiple replicas in different locations in the world. Now, that kind of core-up would not let you distinguish a specific node or a specific client or a specific, within a data center. What that would be useful for is maybe checking content and scale boundaries. Great. So this is kind of the model of the world, how we can introduce the region concept into Filecoin, and really excited about this. One of the really neat things about IPC is that it's so, the design of the subnets is so elegant and strong that we can just do this without having to worry about FIPS. We can just have the subnet actors in the mainnet just start spawning a bunch of regions over time, and we can try them out and see how it goes, try some of the applications, learn from that process before we then go and figure out the FIPS for actually moving the storage providers and all the storage power, because there's a lot of things to work out here. How well is this going to work, and so on. So we can get started and start experimenting with the regional structure before we go and try to do the really hard lift of moving the storage power. Cool. So other cool things that subnets give us, they scale the core protocol. They enable these scalable feature sets whenever the blockchain is too slow for you or too expensive and so on. You can really lean into subnets for that. You can build a whole bunch of components as L2, so things like Saturn, the retrieval network. You can build that as either a single L2 as a subnet, or you can take Saturn itself and split it out into all of the different regions. I've already mentioned on-ramps. You can think about the storage tier concept and start providing something close to what the cloud has, which has very fast tiers at the top, and then those kind of right through all the way to very cold storage at the bottom. And it really lets you kind of now bring and attract truly scalable applications on top of a truly scalable storage network. So because we want the Filecoin network to be a very successful storage network in the world, we need to be able to hit the scalability to get there. So really the concept I want to leave you with is that for all the problems that you want to solve in Filecoin, whether it's a specific application or a specific system constraint that you want to add to Filecoin, or you're thinking about how to scale it, just subnets, right? You get a subnet and you get a subnet and you get a subnet. And if we get the subnet structure right, then the rest will flow here. So now I want to flip it and talk about great. So we just talked about how IPC can make Filecoin awesome and way better. How can a Filecoin make IPC awesome and way better? So let's talk about that for a moment. So first off, Filecoin has a massive scale set of storage providers in the world. Tons of machines operating at massive scale. A lot of these storage providers are always looking for extra business, and so that means that a lot of the IPC networks that need to effectively attract validators or attract worker nodes and so on can offer those services to storage providers, and storage providers can earn money from those networks as well. So first off, the broader Filecoin community is a great community to ship your application into. So coupling with the IPC project there is a really good bet for all IPC adopters, because you have a massive scale network to tap into. This is especially true for all the machine learning oriented use cases where you need a ton of GPUs. The Filecoin network already has a ton of GPUs, and so a lot of your machine learning use cases or any other kind of data processing pipeline things would fit really well here. The second thing is data. So Filecoin is onboarding an enormous amount of data into the network, everything from the small Web3 data to really massive scale archives and scientific data and so on. So that creates an amazing resource to build applications on top of. So for a compute over data network, that's a great place to go. Many other kinds of applications can leverage that data. So that means that for a lot of the IPC project adopters, Filecoin becomes a very interesting place to be able to leverage that data. And there's a really cool way of doing that. So which I'll get to in a moment. So the FVM came out of the Filecoin project, and the FVM is this really awesome hypervisor that we've been talking about all day. That the Filecoin project has that, and that makes IPC much more awesome. But we've been talking about a really cool thing that we can add to the FVM, and this is Raul and a few other people are working on this. A storage state integration into FVM, where you could think of having a syscall directly in the FVM that could store and load data directly to Filecoin systems. And so think of an interface kind of like this, where you would be able to load any data from any subnet directly from wherever it's stored. Like, you might not even care where it's stored. You might be able to have this syscall directly in the FVM to load data by CID, and the node, if the node has the data, can provide it, patch it in, and then run it. Now, of course, you would have to wrap this with some. This is like the easy version. There's a kind of harder version, which is I don't care where the data is, go find it, fetch it, and bring it into the network. That's like a harder. That's kind of like step 2 on an integration like this. But step 1 can be really oriented with subnets. You can use subnets as a way to route these operations to happen in the subnets that actually have the data. So if you map out what parties have the data, you can then figure out which subnets have some particular data sets, and then you go and run these operations directly there because you know that the storage is there. So the easy version to implement this is you add this as a syscall with a simple fault if the data is not around, or something like that. But anyway, so this is like a super cool thing, because that means that a ton of IPC subnets, if we end up with something like this in the FVM, subnets could decide to add this feature to their subnet and suddenly get a massive scale of data directly in their smart contracts, which is super cool, right? Like, being able to compute on a ton of data out there directly in your smart contracts in your subnet. And if you want to do large-scale computation, then think of compute over data networks. So the Filecoin network is becoming this one with a lot of compute over data networks on top, as kind of L2s on top, computing on the valuable data on top of it. Think of being able to leverage those networks, like the connectivity between an IPC subnet and Filecoin can be able to leverage all of that data and all of the hardware that these compute over data networks is going to be organizing. So again, you heard about Lilypad and Bacalao and so on. So think of like these protocols as being able to use that. One other project in this regard is Station, which is a kind of like Filecoin worker node for spare resources. Think of like the long tail of small networks. This might be able to provide a lot of worker nodes for tons of subnets, right? So if you end up creating a very large hierarchy of nodes, you might need a bunch of validators in a bunch of regions of the world. This might be able to collect a lot of nodes. Cool. So I'm gonna pause there, and I have a little bit of space for questions. So if you have any questions, just raise your hand, and we will call on you. Great. Thank you very much.